Hey friends, welcome back. In today's episode, we are diving into something that's becoming increasingly important in modern backend development: how to create agentic systems that operate in real time. If you have worked with agents before, whether in video games or in chat assistants or backend services, you were probably relying on traditional HTTP requests to manage those interactions. But here's the problem: HTTP is request response based, which means the client has to initiate every single interaction. And when you're working with systems that need to respond immediately, systems that are real-time based, like PhiloAgents video game, HTTP might become a bottleneck. And that's where WebSockets come in. So in this video, I'm going to show you how to deploy an agentic system to a FastAPI application using WebSockets, the WebSockets protocol, instead of HTTP. This change will give us a persistent two-way communication between the client and the server, which is ideal if we want to create this real-time environment. By the end of the video, you will understand how to move beyond HTTP, building a WebSocket-based agentic system, one that we believe is much more aligned with how agents are supposed to interact inside a video game. So, if you're ready, let's get started. Hello friends, so welcome to this fourth episode of PhiloAgents. In today's video, as I was saying at the beginning in the introduction, is going to be about how to build real-time agentic systems using WebSockets. And here on the screen you can see a diagram, a simplified diagram of some of the core components of PhiloAgents. But what I want you to focus on is these boxes here, these WebSockets with FastAPI boxes, because this is exactly what we are going to cover in today's video. We are going to cover how we can interact from the Phaser application, from the game UI, with the agentic backend. That's basically everything that you see here. How we can make this interaction possible using WebSockets. The NPC, our player, is going to open or to create a client, a WebSocket client, and it's going to interact with a FastAPI application that is going to send the request or exchange data with the agentic application, with the agentic backend, and after that is going to return a response. It's going to share another data, it's going to share the message that you are going to see in the game UI. Okay, in this case, the player is asking about the Turing test, and the Turing NPC is going to respond with a way to test machine intelligence. Both the question, what is the Turing test, and the answer, a way to test machine intelligence, are going to be shared, are going to be exchanged between the client and the server using WebSockets. All right. Okay, so let's move to the next slide, because you might be asking yourself, why do we need WebSockets? I mean, you have been using, same as I guess, HTTP requests since you started creating things in FastAPI. So why WebSockets? So I have isolated here three main advantages of using WebSockets. The first one is low latency, and this is because, as I was saying at the beginning of the video, with HTTP you need to create a client for every single interaction. Okay, in WebSockets, on the contrary, you create an initial handshake and then you establish the connection, but after that there's an open communication, an open bidirectional communication between the client and the server, and that's exactly what we want. Okay, we don't want to keep opening connections between the client and the server. This is something that's going to stay open for some time. Of course, we are going to put some timeout, but yeah, it's going to stay open, and both the client and the server, in this case the game UI and the agentic application, the agentic backend, are going to be sending to exchanging information, typically the question and the answer. All right, so yeah, first of all, as I was saying, the low latency, because you don't need to create these clients every time you interact. Then we have this real-time interaction, and this is a consequence of the low latency. I mean, there's a real-time interaction because you have opened a connection between the client and on the server, and you can exchange information in real time. Okay, it's bidirectional, which is also a very good advantage. And finally, and this is some crazy idea, scalability for multiplayer. It's PhiloAgents v2, maybe, as I put here. But yeah, I mean, with WebSockets, you open a world of multiplayer. Many of the video games that you might be playing right now that are multiplayer are using this protocol to make the engineering possible. All right, so yeah, that's not so important in this video, but I thought it was worth mentioning as an advantage of WebSockets in case sometime, I don't know, PhiloAgents becomes some sort of video game multiplayer worldwide video game. Although I'm not sure many people will enjoy philosophy that much. Okay, so just to finish this quick theoretical introduction, our use case. What do we want to achieve with WebSockets, and how are we going to introduce this protocol into our architecture, into our diagram, right? So the use case is pretty simple. We have here our PhiloAgents town, and we are going to establish, as I was saying, a WebSocket communication, WebSocket interaction between the game UI and the agentic application. And we are going to define some WebSocket endpoints in FastAPI, in a FastAPI application that I'm going to show you, of course, in the code, but that's exactly what we are going to do. The game UI is going to talk to the FastAPI application, and the FastAPI application is going to take care of taking all the data exchange between the game UI and passing this data to LangGraph to generate a response. And after that, it's going to take the LangGraph response, which is a streaming response, and is going to exchange all of that information using the WebSocket communication with the game UI. And that's exactly the response that you are going to see. Okay, so that's everything for the theoretical introduction. Now let's move into Cursor. All right, so now that we understand how WebSockets work, it is time to see how this is materialized, how this interaction is implemented in the code. So when I talk to some of the philosophers, so who are you, to Ada Lovelace, I send this message to Ada Lovelace, and she responds back with, I'm Ada Lovelace, a mathematician, blah, blah, blah. What is happening is that my question, what is your name, is going to be sent using WebSockets to the FastAPI application, and then this response, I'm Ada Lovelace, is also going to be fetched back, is going to be sent back to the game UI using WebSockets as well. So how is this possible if we go to the Python code? So first of all, if you want to understand how the FastAPI application is implemented, you need to go to source PhiloAgents and inside to infrastructure. And here, just click the API.py. And here you will see a pretty basic FastAPI application, less than 200 lines of code. We start with importing all the things that we've been covering in previous lessons, and some of them, like for example, all the OPIC tools, are going to be covered in the next lesson. But yeah, after that, the lifespan, this is where you handle and you start up, you put all the code for startup and shutdown events for the API. In this case, we are just creating the OPIC tracer. This is something that we will see in next week. Then we are defining the FastAPI application and defining some Pydantic models. But what I want you to focus on is this endpoint, this chat endpoint, and this WS chat endpoint, that is the WebSocket endpoint. So they are both doing the same, the chat and the WebSocket chat, but this one is HTTP based and this one is WebSocket based. Okay, I just created this one for debugging purposes when I was creating this FastAPI application, and I think it's very handy if we want to understand the difference between the HTTP and the WebSocket. If you keep scrolling down, you will also see this reset memory. That is just a call to the MongoDB utils to delete the short-term memory. If you are curious about it, just go to episode 3 of this series, because I covered everything about MongoDB short-term memory and long-term memory. But yeah, this reset memory is just a request that will delete the two collections that were created for short-term memory. If you click this reset game, then a request is going to be sent to FastAPI. All right, so let's begin with the chat, okay, with the HTTP chat. This is not being used in the video game right now, as I was saying, because it's WebSocket based, but still it's interesting to see how it works. So if you go to Docker Desktop, to the Docker Compose application, and you click inside the FastAPI application, let's go to Docs, you will see there are two endpoints, the chat endpoint and the reset memory. So if we focus on chat, this is something really easy to use, and you can see that the response is exactly what we expected, although it's not streaming. But here in message we can put what is your name, and let's ask Play-Doh, for example. Okay, so if we execute this, after some time we will get the response. So I am Play-Doh, a philosopher from Athens. I invite you to join me on the journey of discovery, etc. This is exactly the same response that we will get if we ask Play-Doh inside the video game. All right, so let's go to the video game again. And so if we go here and we ask Play-Doh, we will get something pretty similar. But of course, we are not using HTTP for our request. We are using WebSocket. So how can we implement this same logic, calling the language workflow, etc., generating the response, but with WebSockets? Okay, so this is exactly the code that we are going to use. First of all, it's going to accept the connection. So the connection is going to be established between the client and the server, the game UI and the agentic backend, in this case, the FastAPI application. And then we are getting the data, right? So WebSocket receive JSON. We are getting all the data that's being exchanged using the WebSocket communication. And after that, we are defining some cases where there is no message or the philosopher ID is not in the data, etc. In that case, we are going to generate an error that we are going to send back to the client. But then here in the try block, you can see that we are doing exactly the same as here. There's a small difference because here we are getting a streaming response. That makes sense because of the real-time nature of WebSockets. We are not waiting for the response to be generated and then sending back the data using WebSockets. We are sending all the different chunks, all right, using the WebSocket protocol. And then the client in the game UI is going to take each one of these chunks and compose the final response, the final block of text. All right, so yeah, this is the get streaming response. This is one of the use cases we defined inside the application folder. The get streaming response is just going to create, to call the language workflow with a streaming fashion. Okay, this is something that we covered in lesson 2 when we were speaking about the different language implementations that we have made. But yeah, this is the get streaming response, and we will get this response stream variable. We will have the streaming data. Okay, after that, we are just sending an initial message to indicate that the streaming has started. And after that, we are going to stream each one of the chunks of the response, okay? Remember that response string contains different chunks of the streaming data. And what we are doing here is just to send all the different data, all the different chunks of data to the client, okay? So yeah, we are sending this JSON, the chunks, under the chunk key in this dictionary. And after that, we are just sending the full response, okay? Just to have the full response. And this is the moment when we indicate the client that the data has finished, okay? Because we are sending the streaming as false. And that's basically it. That's basically how we are going to deal with WebSocket in FastAPI. You can see how easy it is. You just need to put this WebSocket in the path and also define app WebSocket instead of app.post, okay? But with that, you have your own WebSocket endpoint that you can use for your real-time applications. Okay, so this is for the backend part. This is, you can put it as the server side, okay? But remember that we also have a client in the WebSocket connection. And where are we defining this client? Well, of course, you might be aware of the answer right now. It's in the PhiloAgents UI. It's in the game UI. If you go to services and to the WebSocket API service, you will see this class that manages the creation of the connection between the client and the server. It's going to establish the WebSocket connection between the client and the server. And it has a few interesting methods, like for example, this connect. Remember that this connection is one of the first step to the handshake. We have this connection established. So this is exactly what this connect is going to do. And we are defining all of this JavaScript code, but at the end, we are just establishing the handshake between the client and the server and just establishing the connection. Once this connection is established, we also have different methods for handling the messages and also for sending the messages, okay? Because we need to handle the incoming messages, the ones that we are generating right here from the streaming response from LangGraph, and we also need to send some messages, okay? That's exactly the message that we saw at the beginning, where I was asking Ada Lovelace, what's your name? All right, so that's exactly the kind of message that we need to send here, okay? And this message, of course, is going to be obtained here. It's going to be received in this data receive JSON, all right? But that's basically it. Then we also have some register for callbacks, but for the promises that I have implemented here in the connection. And lastly, we have this disconnect that is going to close the connection between the client and the server. And this is something that can be called either because we manually run this method or because we have achieved some timeout. All right, so if there's a connection open between the client and the server, between the player and the NPC for a lot of time, then the WebSocket connection is going to be closed automatically. But that's basically it. You can see how easy it is to add this WebSocket logic to your agentic systems. And I believe that this makes a huge difference. Of course, not for the typical, assistant, chatbot assistant, or some typical backend services. But if you want to build something close to this video game experience, something that demands the real-time interaction, or maybe something that is going to be capable of hosting multiple players playing at the same time, then I believe WebSocket is the right tool. It's the right protocol to use. But yeah, this is everything. I hope you have found this video useful. Let me know what additional use cases you might be thinking of to apply WebSockets. So yeah, this is everything for today. I'll see you next week, where I'm going to cover OPIC, agent evaluation. I'm going to give you a crash course on OPIC and how to version the prompts, how to evaluate the RAG applications, how to trace all the different conversations, etc. But until that time, happy coding and have a very nice week. Bye bye.